All right, here's some solutions to the rest of today's classwork. Hopefully you have tried these on your own first and then you can follow along. If you haven't even read or tried them, I encourage you to pause and then go ahead and try them a little bit on your own first. So this first one is like 7.1 problems, and we're going to be dealing with a sample proportion. Based on our given sample proportion, we're going to construct a confidence interval. We're going to focus on using our calculator. So in this one, our statement is we have a drug company that's using a drug to help prevent blood clots, which would prevent heart attacks. They did a sample of 5,925 people. Get to my drawing tools here. And they said that, so here's our 5,925 people, and 153 of these people developed an adverse, which is a bad negative reaction of having nausea, feeling sick to their stomach from taking that drug. So we have one sample proportion. At this point, they don't tell us a proportion yet, but I know it's a proportion because they haven't told me a mean. They've told me how many people out of the total I'm dealing with. That's a proportion. Then when I go on to finish reading the problem, they want me to construct a 99% confidence interval, and then they tell me the actual proportion. So in terms of things that I'm given, and the questions that we wanted to ask ourselves, so the first question is based on asking if, let's see if I can actually get down here. So the first question we want to ask ourselves, is this going to be a proportion? Is this a proportion or a mean? So this one we know is a proportion because they tell us in the end, find a confidence interval for the proportion, and because we're given a number out of the total. So once I know it's proportion, I need to find p hat, the sample proportion, which is equal to x out of n, the amount of people that had what I'm researching out of the total. Because on my calculator, I need the x in the n. So in this particular problem, they actually gave me the x in the n. I don't need to find p hat. If they ask me about that later in the problem, my calculator will actually give that to me. So the x here is 153. That's the people who got nausea out of my sample set of 5,924. Remember, in order to apply doing a confidence interval in this way, I either need the data to already be normally distributed, which they didn't mention here, so I can't assume that, or a sample size over 30. 5,924 is a nice big sample, certainly over 30, so we can carry on, and our confidence interval would be trustworthy and meaningful. So even though this is a large sample, it's still only a sample. This is not the entire population of all people, right? There's way more than 5,924 people on the planet, or even that would be patients attending a certain healthcare institution. They didn't really define exactly what the population is, but certainly this is not going to be the entire population. Then I'm going to put these things into the calculator. Because it's a sample proportion, that means that I am going to go into my calculator for tests, and I am going to use the one proportion, because it's a proportion, z test, or z interval, because we're doing an interval. So I'm going to go to my calculator, I'm going to turn it on, I'm going into stats, I'm going to go into tests, and I am going to go down till it's the intervals, and here is my one proportion z interval. I know it's a proportion because they told me it's a proportion. It's one because I only have one proportion. I'm only dealing with one sample, and I'm using a z interval because we discussed that that is the best thing to use for proportion. You can also kind of tell from the calculator for my one proportion, that's the only option they're giving me. There's no other interval for one proportion. So I'm going to choose that. And then it makes sense that I picked the right thing because my calculator is asking me for the data I have, X, N, and the confidence level. So X in this case, the number of people that got sick is 153. N, the size of the sample set, is 5,924. And now the confidence level they're asking me for is 99%, which as a decimal is 0.99. Then my calculator will go ahead and tell me what is that interval. So the final response is going to be, I am 99% sure that the real proportion of people who would get sick from this drug is going to be in the interval my calculator is going to tell me. So the calculator is giving me the interval between 0.02, let's round to 3 decimals, between 0.021, I'm rounding this up because I have a 5, and 0.031. This one stays a 1 because the place after it is a 1. It found the p hat for me. If I were to divide this 153 divided by 5,924, I would get 0.0258, right? So p hat is about 0.026. So let's jot all this stuff down. So we got that p hat is equal to 0.0256. That's about 2.56% of people got sick. And then the interval it gave us, and I'll write it the way the calculator writes it so we can kind of go from there, is going to be 0.021 to 0.031. So 0.021 to 0.031 when I round to 3 decimals. So what does that mean? The intervals are telling me the lower bound and the upper bound for my interval. So now you want to kind of answer the question in words. So what this means is that I am 99% confident now. 99% confident that the actual proportion of patients getting sick, which is this kind of sick is nausea, of getting sick, nausea, spelling is not my strong point, of getting nausea is going to be in this interval where it's between 0.021 is going to be less than the real proportion, so not p hat now, just little p, and 0.031, right? In other words, between 2.1% and 3.1%. If we wanted to find the error, remember we have this 2 methods. I'm going to use the method that they gave us in the slides. I can take this upper bound minus my lower bound and divide by 2. And when we do that, we are going to get 0.031 minus 0.021 should be 0.010 divided by 2 is going to be 0.05. So in other words, my error margin is about 5%, right? The other way you could do that is this 0.031 minus this 0.025. And I think I did something wrong here. 005. I divided wrong. So it's about 0.5%, right? And if I did this 0.31 minus this 0.025, or if I rounded to 0.026, I'm going to get the same distance. In other words, if I take my sample proportion, the 0.0256, I am 99% sure that the real sample proportion is either 0.005 less or 0.005 more. Within that margin of error, I am 99% sure that the real actual proportion of people who would get sick from this drug is going to be. And let's do another one. So this is also from 17.1. And this one is also about a sample proportion. So this is again with fast food at a drive-through. So now they're saying that they want the study of the accuracy of fast food drive-thrus. We did one like this with McDonald's. So this one is for Burger King. We had 264 accurate orders and 54 orders that were not accurate. So this is a nice problem to practice with because, again, we need to figure out what are our X and our N. We want a 99% confidence interval for the percentage of orders that are not accurate. So my X is what's not accurate, which they told me is 54. What I need for N is the total orders. They didn't give me that, but I can figure it out because total orders is everything that is either accurate or not accurate. So all of those together are going to be my total. So N is going to be the 264 accurate orders plus my 54 not accurate orders, which should, if I added correctly, give me 318 total orders. Now I'm going to put this in the interval again in my calculator, right? We can move a little bit faster this time because we've been doing it more. So I'm going to stats. So I guess I have to turn it on first. Stats. And then I'm going to go to tests. And then this is, again, one proportion. I'm not doing a test yet. I'm doing an interval. So here's my one proportion, Z interval. Now I'm going to put in my X, which in this case we said was going to be the 54, because I want an interval for things that are not accurate. And my N, which we had to compute by adding together, to be 318. And in this case, we also want a 99% confidence level, 0.99. And then when I hit calculate, I'm going to get this interval between, if I round up here, let's round to 4 decimal places in this case, 0.1698. Sorry, I'm going to get between, my p hat is 0.1698. And I am going to get my interval to be between 0.116 and 0.224. Right? So from the calculator, I get 0.116, comma, 0.224. It also gives me the p hat, which is the x over n. So in case I was interested in that actual proportion, the x over n is 0.1698. Right? So about 16.98% of those 318 orders were not accurate. And now what I'm saying is, based on that, I'm going to conclude that I am 99% confident that the inaccurate orders for the whole population are going to be between this interval between 0.116, should be smaller than my real answer, which is smaller than 0.224. So I'm 99% confident that given in my sample, I had almost 17% inaccurate orders that I would have in real life for the whole population. I think the real true proportion is between 11.6 and 22.4. Notice again, I'm more confident. This is a bigger interval than some of the ones we've seen. That's how I can be more confident, right? Like when you guys said my age was between 30 and 100, you're really confident the real age is in between there. But if you're saying between 48 and 49, even though that's close, right? You didn't get the real age, I'm 50. You're not going to be as confident the smaller that interval. So now notice when I'm more confident, I need a bigger interval, I'm going to have bigger error. If we wanted to find the error, which they did not ask us to find in this case, they're usually not going to ask you about the error because they're assuming you're doing this by hand, where you're using that really ugly formula to find the error the long way and then using the error to build the interval. We're using technology, much more efficient, to come up with the interval and just making sure we understand the interval. So the error would be 0.224 minus 0.116. I'm just going to do it the one way this time, using the both endpoints. Whoops. And then dividing that by 2. And if I do that correctly, we should get about, looks like 0.0543. So that should be about my error. So in other words, I have a sample with almost 17% errors. I'm pretty sure, give or take, a little bit more than 5% is the real percentage of errors. So in part B, now they're saying, compare this to a 99% confidence of orders at Wendy's. So this is Burger King. So let's kind of, by the way, just also write this in percent. That would be 11.6%. Right? Move the decimal over twice, and 22.4%. So my real percentage of errors at Burger King, so the inaccurate orders at BK, are between 11.6 and 22.4. In part B, they're saying that Wendy's confidence intervals are between 6.2% and 15.9%. So what can I conclude? Basically, they're kind of the same, right? At first glance, you want to say Wendy's is better because this lower bound is lower, but it doesn't really matter. That's a pretty big spread. So the easiest way to see that is to graph it. So if I were to draw a graph and label these numbers, and we'll end on this problem, maybe if I can actually draw my graph. No. Let's see if we change colors. There we go. So somewhere over here, 0.2, somewhere over here is 11.6, somewhere over here is 15.9. I'll write it up here so you can see. And then somewhere over here is 22.4. Notice they cover almost the same thing, right? Wendy's goes from 6.2 to 15.9, and Burger King is from 11.6 to 22.4. they both have this huge chunk of the same percentage likelihood of inaccurate orders. So ultimately, they're pretty much the same.